There are two really simple common types of sequence. One is called arithmetic sequence, and the other is called a geometric sequence. And here's an example of each. Why don't you take a minute and look at this and see what's the pattern? How could you predict what the next term was? And then how could you predict in this sequence what the next term is? So unfortunately, I don't have different pen colors here, but 7 plus 8 is 15. 15 plus 8 is 23. 23 plus 8 is 31. So this one has linear growth. This one you're constantly adding. So this is an example of an arithmetic sequence. An arithmetic sequence is one where to get from one term to the next, you add a constant that's always the same. If I was going to write this recursively, I could say the nth term equals the previous term, the n minus first, plus some constant g for growth. So this is kind of one way you could define the type of growth for an arithmetic sequence. In this one, you might notice that we are multiplying by 2 to get from each term to the next. So here, if I was going to write this down recursively, I would say that the nth term is the n minus first term times some constant growth. So here it's constant additive growth, here it's constant multiplying growth, multiplicative growth. Okay, so one of the things that you're asked to do is just can you recognize if one of these two things is happening, or you do have a sequence that's neither of those. A different thing you might want to do is how could you like write down this pattern in general so that you could predict some really high number term? Like let's say I wanted the 352nd term in this sequence. What could it be? So let's write an equation that will tell us what the nth term in the sequence is. Well, we already have a recursive one here. But let's write an explicit one so that way we could plug in 352 as our n value, and it would just tell us what it is. Clearly, this is linear growth, so you could figure out a function where these are the y values for x values of 1, 2, 3, and so on, and that would work. Let me give you an equivalent way of thinking about it that sort of fits the picture we have here. I'm going to describe it as how I get to the nth term starting from the first term. So remember, this is a sub 1, that's the first term. So to get to the, let's get to the fourth term, for example. To get from the first term to the fourth term, I start at, here's fourth term. So the fourth term is a sub 1, and then I have to add g 1, 2, 3 times. So I'll add 3 g's. If I was going to get to the fifth term, this mystery one out here, I would start at the first term and I would add g 1, 2, 3, 4 times. So the fifth term is plus 4 g's. So clearly you could generalize this. If I wanted the nth term, I'll start with the first term and then I'll add n minus 1 copies of g. So this equation comes from a very simple-minded idea. I'm just starting at the beginning of the sequence, and then I'm describing how you get from each term to the next term. So being able to rederive this and use this is going to be important in your work for this problem set. Let's see if we can do the same thing over here. Why don't you see, so here's a sub 1, here's a sub 3, wait, sorry, that's a sub 4, a sub 5. So let's see if you can do the same thing. A sub 4 equals a sub 1, but then you fill in the rest of this equation, similar to this one on this side. What do you have to do to get from here over to there? And then same thing for this one. What do you have to do to get from a sub 1 over to here? Give it a try. Okay, so in this case, it looks like I'm multiplying by 2, and then 2, and then 2. So it's like times 2 times 2 times 2. But this is the same thing as an exponent. So this is like saying times 2 to the third power. Here, to get to 5, I have to multiply by 2, 1, 2, 3, 4 times. So this is times 2 to the 4th power. And in general, if I have the nth term, the way that I get there is I start at the first term, and then I multiply by whatever my growth is, n minus 1 times. Because to get from one term to the next, you have to multiply by g. So, so these are the equations for getting the nth term for an arithmetic and a geometric sequence.